Today we're going to solve rational equations. This problem we probably should already know how to do. We can just use our cross products to solve this. There is another way, which I'll show you in the next slide, of when it's not just one fraction equal another, but if you do have just one fraction equal another fraction like this, you can always use your cross products. So it would be 12 times the quantity x plus 2 is equal to 4 times the quantity x plus 5. And you just distribute 12x plus 24 equals 4x plus 20. What kind of equation is this? This is a linear equation because it just have x's, so we need to get our x's on one side, so I'm going to subtract 4x from each side. I think I'm going to do two steps at once here, so since I'm bringing my variables to the left, I want to bring my numbers to the right, so I'm going to subtract 24. So if I subtract 4x from each side, I get 8x. If I subtract 24 from each side, I'm going to get negative 4. Our last step would be to divide by 8 and reduce your fraction. 4/8 reduces to 1/2, and there is a negative sign, so x equal negative 1/2. It is important to put it back in your denominator to make sure that it does not give you 0, and negative 1/2 in either denominator here will not give us 0. That's fairly obvious. So if you just have two fractions equal to each other, you may use your cross products to solve that. Now in this one, we don't just have two fractions, so we can't use our cross products. So, and we've really done this before when it was numbers, remember, we want to get rid of those fractions. What do? We multiply by the common denominator. So in this case, the common denominator would be n, we need an n, and we need an n minus 6. So I'm going to multiply every fraction by n times the quantity n minus 6. Kind of hard for me to write it all here. N times the quantity n minus 6, and n times the quantity n minus 6. Then we're going to do my canceling, so here the n's cancel, leaving me n minus 6 times the numerator, n minus 2. We have minus. Here the n minus 6 cancel, leaving me n times the quantity n minus 3. Over here the n's cancel, leaving me n minus 6. So I no longer have any fractions, which is what my goal was. So I just need to go ahead and multiply. So using the FOIL method here, I'm going to get n squared. Minus 2 minus 6 would be minus 8n. Negative 6 times negative 2 would be plus 12. Here I'm going to distribute a negative n, so I get negative n squared plus 3n equal n minus 6. I'm going to simplify. N squared minus n squared is gone. Negative 8n plus 3n would be negative 5n plus 12 equal n minus 6. So since my n squared terms did subtract away, I now have a linear equation again. So I need to get my n's to one side, so I'm going to subtract n. At the same time, I'm going to get my 12 to the right, so I'm going to subtract 12. So subtract n, I'm going to get negative 6n. If I subtract 12, I'm going to get negative 18. My last step would be to divide by negative 6 and get n equal 3. Again, don't forget to put it back in. If I put it back in my first denominator, 3 is not, and 3 minus 6 is not equal to 0, so n equals 3 would be my solution. Again, we need to look at our denominators because we have more than two fractions and find the common denominator, which in this case would be a times the quantity a plus 1. So I'm going to multiply every fraction by that, or every term actually. Even though this isn't a fraction, I still have to multiply it by to keep everything equal. So the a plus 1's cancel, leaving me negative 4a, plus the a's cancel, leaving me 3 times the quantity a plus 1. And over here, nothing cancels, just leaving me a times the quantity a plus 1. So, distributing, I'm going to get, whoops, shouldn't be an equal sign there, plus sign, 3a plus 3 equal a squared plus a. You can go ahead and simplify this side if you want. It's going to be negative a plus 3 equal a squared plus a. So now notice I do have a quadratic equation. So I want to get everything with my a squared terms, and I'm going to bring them to the right because I like to keep my a squared positive. So I'm going to add a and subtract 3. So that gives me 0 over here, a squared. If I'm adding a, I get 2a. And I'm subtracting 3, I get minus 3. So this is a quadratic that I would need then to factor. A squared would be a and a. Factors of 3 are going to just be 3 and 1. you need the bigger one to be positive because you're a positive sign, so plus minus. So what would A equal? From this first one it would be -3, and from the second one it would be 1. Again, put it back in. Does anything give you 0? Well, 1 plus 1 does not, and -3 does not, so you would be okay there. Looks like we're going to have to do some factoring here. So we factor the second one into, it's a difference of squares, so n minus 1, n plus 1. This would be the same if I factor out the -1. Now I'm going to take that negative sign, I'm going to move it up here and put it right there. So now it's not in my denominator. So I'm going to multiply by n minus 1, n plus 1 on every term. So there and here. Didn't look like it there, but that's what that's supposed to be. N minus 1, n plus 1. So here my n minus 1's cancel, leaving me -2n times the quantity n plus 1. Here, n minus 1 and n plus 1 both cancel, just leaving me plus n plus 3. If that were a minus, you need to keep the n plus 3 in parentheses, equals quantity n minus 1 times the quantity n plus 1. So distributing, I get -2n squared minus 2n plus n plus 3. Over here I'm going to get n squared, and then my middle terms cancel, so minus 1. Simplifying on this side, 2n squared, -2n squared, -2n plus n would be -n plus 3, equal n squared minus 1. So it does look like it's a quadratic, and again, I like mine positive, so I'm going to bring my everything to the right side. So I'm going to add 2n squared, I'm going to add n, and I'm going to subtract 3. So see if I can do that all at once here, one at a time. But so if I add 2n squared, I'm going to get 3n squared. If I add n, I'm just going to get plus n. Subtract 3, I'm going to get -4. So now I need to factor this. Again, I kind of use the guess and check method. If you want to use the method where you multiply the 3 and 4, that's fine. You're looking at factors of 12 that differ by 1, but I usually use this method, so whichever. I guess I can show you that method here in a minute. So factors of 4 are going to be either 2 and 2 or 4 and 1. And since I want them to differ by 1, I'm going to use 4 and 1. They do need to be different, but I want the bigger one to be positive, so let's try a positive here and a negative here. And let's check it out. That gives me 3n squared. That gives me -3n in positive form, which would work for plus n, and that would work. So remember, if you're doing it the other way, let me kind of come up here and show you that other way. You take the 3 times 4, we get -12, so we're looking at factors of -12, so it's 3n squared, and then it would be plus 4n minus n, and then minus 4, and then you group them. Make sure this is plus -n. So you factor out here an n you have in common. I think something's wrong here. So what did I do wrong here? Well, I'm supposed to get 1 when I subtract them. So I need to use a factors of 12. Oh, well, this should have been a 3 in there. That's what I lost. I lost my 3. So that's -3n, sorry. So when I factor out my n, I'm going to be left with 3n plus 4. Here I'm going to factor out a -1, leaving me with 3n plus 4. Getting a little sloppy here. So now I have a 3n plus 4 in common, leaving me 3n, just n minus 1. Can't read all that, but same thing I have down here. So when I set it equal to 0 and factor, from this first one I'm going to get -4/3, and from the second one I'm going to get 1. If I do put those in, notice that right here, 1 minus 1 is 0, so I need to throw that one out, and this is my only answer in this case. So remember, that can happen, so you need to check every time to see if